Ever wondered why so many software projects just fail? Or why they blow past their budgets and deadlines? It's usually not about bad code. Nope. It all comes down to a critical first step that so many people get wrong. We're going to talk about the discipline that can literally make or break a project before a single line of code is ever written: requirements engineering. And look, this quote from the legend Fred Brooks just nails it. The absolute hardest part of any software project is right at the very beginning, deciding what you're actually building. If you mess that up, well, everything you build after that is just sitting on a really, really shaky foundation. And just to really drive the point home, Capers-Jones points out that these huge disasters, they don't just pop up out of nowhere. The seeds are planted right at the very start. So those first few decisions you make, they have massive, and I mean massive, consequences down the line. So let's talk about that. Let's dig into where those seeds of disaster actually come from. It's really as simple as this. If you don't have a crystal clear, totally shared understanding of what the software is supposed to do, you're basically setting yourself up for failure. And it's a failure on both sides, right? The developers waste a ton of time building the wrong thing, and the customer ends up with a system that doesn't actually solve their problem. But hey, this isn't some unsolvable mystery. There's actually a structured discipline designed to prevent exactly this kind of mess. So let's flip this around and look at how we can engineer a real solution and pave a solid path to success. And here it is: requirements engineering. Now, don't think of this as just a bunch of boring paperwork. It's a systematic process. It's about getting in there and deeply understanding what the customer actually needs, analyzing all of it, and then creating a super clear, unambiguous plan for the solution before the really expensive part, the coding, even starts. This is where you save the big bucks. So, what does this whole process actually do for you? Well, it makes sure you're meeting the real needs, not just what someone said they wanted. It checks if the whole idea is even possible. It helps you negotiate a plan that's actually realistic. It creates that clear specification, makes sure it's correct, and this is a big one: it gives you a way to manage all the changes that are definitely going to come up later. Basically, you're replacing guesswork with a clear, agreed-upon plan. Now, to get this right, you have to understand the two fundamental building blocks of any requirement. This is key. Okay, I love this slide because it's so simple and powerful. Pretty much every requirement you can think of fits into one of two buckets. You've got functional requirements, which describe what the system does, its features. And then you have non-functional requirements, which describe how it does it. Things like its speed, its security, its reliability. One is about the features, the other is about the quality. Let's make this super concrete. Imagine a library system. A functional requirement is that a librarian can add or delete articles. That's a what. A non-functional one: the system has to perform daily backups to keep the data safe. That's a how. See the difference? It's not a new feature, but it defines a critical quality of the entire system. Okay, so how do we actually get from some vague idea in a meeting to a set of clear, actionable requirements? Well, you guessed it, there's a roadmap for that. This 7-step process is your guide from start to finish. You start with inception, just getting a rough idea of the problem. Then elicitation, where you go out and gather all the info. Elaboration and negotiation are all about refining those ideas and making sure they're realistic. Then specification, that's where you write it all down formally. And finally, validation and management, make sure the plan is right and that you can handle changes as they come. But of all those steps, one of them is consistently the toughest, the one where teams get really stuck. And that's elicitation, just the simple sounding act of gathering the requirements. So why is this one step so tricky? Well, it usually boils down to three things. First, scope issues. The project's boundaries are all fuzzy. Second, problems of understanding. Your customer is an expert in their problem, not the solution. So a lot of times they don't really know what they want or what's even possible. And third, volatility. This is huge. Requirements always change. It's just a fact of life. So after you navigate that whole difficult process, you arrive at the main goal: creating the one critical document that acts as the blueprint for the entire project's success. And that document is the Software Requirements Specification, or SRS. Seriously, think of it as the project's official blueprint. It describes in perfect detail what the software will do, but, and this is important, it intentionally leaves out the how. The how is for the designers and developers to figure out later. The SRS becomes the single source of truth that everyone can turn to. But you can't just throw any old document together. A good SRS has to meet some high standards. As you can see here, it's all about clarity. It has to be correct, unambiguous, and complete. It's got to be testable, that's verifiable, and it has to be practical, consistent, easy to modify, and traceable, so you can always track what's most important. So here's the bottom line. Without a high-quality SRS, you get chaos. The developers are basically flying blind, just guessing at what to build. And at the same time, the customer has no clear picture of what they're actually going to get. It is an absolute recipe for disaster. And that brings us to the final big thought here. We know for a fact that requirements are going to change. That's a guarantee. So the real question isn't, can you stop change? Because you can't. The question is your process strong enough to handle it? Is your blueprint built on solid ground, but still flexible enough to adapt when it needs to? That, right there, is the true mark of success in this game.